This video is over lesson 31, adding integers and collecting like terms, and it is for my pre-algebra classes. So first of all, ladies and gentlemen, we need to review what does an integer mean. Integers are all natural numbers. Remember, those are the counting numbers. So 1, 2, 3, 4, 5, and on and on. They're opposites, so -1, -2, -3, -4, -5, and on and on and on, and 0. So these are the places where typically on a number line we put our tick marks. Again, we don't have to put our tick marks there. Sometimes we put less, sometimes we put more, but they're the typical place they go. So with that being understood, we're going to take a look here at adding integers first. And go ahead and grab a highlighter. I don't actually care what color you choose today. I'm going to choose blue, so if you want to match me, you can choose your blue as well. And we're going to start with a real easy example, 4 plus 5. Now, hidden here when we say 4 plus 5 is that these are both technically positive. So this is really a positive 4. And so just like the negative sign looks like a small minus sign, we have a positive sign that looks like a small plus sign. But since positive numbers are typical numbers, we don't usually have to put the sign on. So no sign, we assume it's positive. Now I know you already know the answer to this, 4 plus 5, but that's not the point. The point is to understand what's going on when we add integers. So if we think about diagramming this, I'm going to go ahead and make a number line here. And I'm going to start at 0 here on the left, and I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at least 10 spaces there. 12, 13, I got a few extras here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I got a couple extras. So to diagram an addition problem, we're going to always start at 0. And so I make a tick mark above 0 saying this is where I'm starting, and then we draw arrows. So my first number is 4, a positive 4. Positive tells me to go to the right. So I'm going to go to the right 4 spaces, and I'm going to label this arrow. There's my 4. Now my next arrow is going to start where that one left off. And the positive 5 tells me to go 5 more. 1, 2, 3, 4, 5 more to the right. So if I look at where we end, I've ended at 9, which is why 4 plus 5 is 9. Or, of course, positive 9, though we don't have to write the positive symbol. All right, that should come as no surprise. But with that understanding, let's take a look at what happens if I have -4 plus a -5. So it can help if you take your negative and your positive signs and just push them up a little bit, especially if you've got a plus sign and a negative sign right next to each other. Pushing it up makes it a little more obvious it's a negative. In the book, you'll notice that they throw parentheses around those negatives and positives a lot of times, so that way you understand there is a difference between a positive and negative, even though they are related. So anyways, for this guy, I'm going to set up my number line likewise, but I'm going to start with 0 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to get at least 10. Again, I got a few extras here. Now this one I got to really write kind of small for, because since we're going to the left, it's going to be negative. So negatives send me to the left on a number line. And just like before, we're going to start at 0. Now this time, the -4 sends me 4 to the left. And I'll label that arrow. We start where we ended, and a -5 will send me 5 more to the left. So 1, 2, 3, 4, 5 more to the left. So plus a -5 there is what's happening. So where I end here, that's the answer to -4 plus -5. So -4 plus -5 equals -9. So one thing to notice about both of these problems is here they're both positive to start. Here they're both negative to start. So in these problems, we would say that they have the same sign. So positive, negative, that's the sign of the number. So these have the same sign. And what we've hopefully just discovered that is if they have the same sign, so they're both positive or they're both negative, then to find the number of our answer, we are going to just truly add. So 4 plus 5 gives me 9. 4 plus 5 gives me 9. So if they have the same side, add the numbers. Now, that's not all we have to worry about. We also have to worry about the sign of the answer. So we got the number of the answer, but what about the sign of the answer? Well, if they were both positive, the answer is positive. If they were both negative, the answer is negative. So we're going to add the numbers and keep the sign. So when adding integers, if they have the same sign, we will actually truly add the numbers and keep the sign. So if they were both positive, the answer will be positive. If they're both negative, the answer will be negative. So ladies and gentlemen, this should raise a question in our minds about what happens then if they have opposite signs or different signs. So let's take a look at negative 4 plus 5. And of course, when we say 5, we really mean positive 5. So if I make a number line out of this guy, this time I'm going to stick 0 in the middle, and I want to go 1, 2, 3, 4, 5 in each direction if I can. 2, 3, 4, 5. So negative 5, negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4, and 5. So we start with 0. And my first number, negative 4, negative would send me to the left. So if I go to the left 4, 1, 2, 3, 4, that's my negative 4. And then we start where we left off, and a positive 5 would send me back to the right, 1, 2, 3, 4, 5. So there's my plus positive 5. And so we end at 1. So the answer ends up being 1, which of course is a positive 1. Okay. Well, let's take a look at what happens if we switch the signs around. So what if it's a positive 4 and a negative 5? So I'll put the positive sign there in red because we should be thinking it. We're not actually going to write it usually, but we're thinking it. So 0, 1, 2, 3, 4, 5. I got 6 in this direction. That's okay. At least 5. 1, 2, 3, 4, 5, 6. Same idea here. I'm going to start at 0. Positive 4 this time tells me to go 4 to the right. So there's my 4. And then if we start here, plus a negative 5 would send me 5, 1, 2, 3, 4, and then 5 to the left. So my answer is a negative 1. So when adding integers, if they have different signs, well, let's look at how do we find the number. So we had a 4 and a 5, we got a 1. We had a 4 and a 5, we got a 1. So it looks like this time, because the signs were opposite, what we're actually going to do is subtract the numbers. So 5 minus 4 is 1, 5 minus 4 is 1. Now for the sign, you'll notice that in both cases, the sign of the answer matches the sign of the 5. So when 5 was positive, the answer is positive. When 5 was negative, the answer is negative. Well, if you consider the relationship between 4 and 5, 5 is bigger. So it would seem here, and if we look at the arrows, we can see it too, that the number with the larger arrow is going to win. You're going to end up on its side of the number line. So if the positive number has a bigger arrow, you're going to end up on the positive side of 0. If the larger number is negative, you're going to end up on the negative side of 0. So we're going to subtract the numbers and keep the bigger numbers sign. The bigger numbers, should be an apostrophe S, bigger numbers sign. And since that all has to do with adding, I'm going to keep doing this in this same color here. So ladies and gentlemen, when you need to look back at your notes to remind you about this, so adding integers here I have in blue. These are the two rules for adding integers. So whatever color you chose, hopefully you've matched those colors like I have, and that way you can quickly refer back to what should you do. Well, if they have the same sign, do this. If they have different signs, do that. And we'll practice this more in just a second. Before we get there though, we have another concept related to adding integers that we're going to tackle here, and that is subtracting integers. And so this time I'm going to choose a different color. I'm going to choose my green. So again, if you want to match me, grab your green. And so for this one, let's take a look at what happens if we have 3 minus 6. Now this is really a positive 3. I'm sorry, actually no. I'm going to change my mind about that. It was an old example. No, we're going to go 4 minus 5. There we go. 4 minus 5. So a positive 4 minus a positive 5. A positive 4 minus a positive 5. So for this diagram, I'm going to start in the middle with 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Put my labels on. So the first number is nice and simple, 4. It's a positive 4, so it's going to go out to the right 4. Now, since subtraction is the inverse of addition, it undoes addition, or you could look at it this way, it works backwards from addition. So whatever plus would do, minus will do the opposite. So positive 5 normally would send me 5 to the right, but since it's a minus positive 5, it'll actually send me to the left. The minus will do the opposite of whatever the plus would have done. So 1, 2, 3, 4 sends me back to 0, and one more, so minus a positive 5, gives me an answer of -1. Now before I actually write that answer though, I want you to take a look up at your other diagrams here. And hopefully if you do some quick comparisons, you'll quickly see that there's another place where we got the answer of -1. And that's right here. So it turns out that a positive 4 minus a positive 5 has the same answer as a positive 4 plus a -5. And that's -1. For that matter, let's do another example here. Let's do 4 minus a -5. And of course, when we say that, it's really a positive 4. And so to diagram this one, I'm actually going to start with 0 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to get at least 10 and there to the right. Fill in the rest of your numbers there. So just like before, 4, the first number is always nice and simple. The first number we're just going to do. So positive 4 sends me 4 to the right. Now remember that a minus will send you the opposite of wherever a plus would have. So a -5 would normally send me to the left, but because it's minus a -5, it will actually send me to the right 1, 2, 3, 4, 5 spaces. And so my answer is 9. And likewise, was there an answer up here that turned out as 9? There was. Positive 4 plus positive 5. And what we've discovered here is the key to subtracting. We've discovered the key to subtracting here. So when we have subtracting integers, notice that the first number stays the same. So if this is a positive 4, it's still a positive 4. If this is a positive 4, still a positive 4. But notice what happens to the second number. Here it was a positive, but then it became a negative. Here it was a negative, but then it became a positive. So if we put this together, we've just discovered that subtracting by a number is the same as adding its opposite. And once we've turned it into an addition problem, we can just go ahead and follow the rules for addition. So let's try a few practice problems. Negative 4 minus 5 equals negative 4 and then plus its opposite. So this is really plus negative 5. I can't talk right now. Sorry, that was my son. Now we follow the rules for addition. So since these have the same sign, they're both negatives, we're going to add the numbers. 4 plus 5 is 9, and then keep the sign. So since these are both negative, this is a negative. Negative 9. 6 minus 8, which you may actually be able to do as a subtraction problem, but still we want to practice this skill. So the first number stays the same, and then minus a number becomes plus its opposite. So this will be plus, and then since this is a positive 8, that'll become a negative 8. So these have different signs, because that's a positive, that's a negative. So we are going to actually subtract the numbers. So 8 minus 6 is 2. And then we're going to keep the bigger number sign. So the bigger number is 8. It's negative, so this is a negative 2. If we try a negative 7 minus negative 9, first number always stays the same. So negative 7 is negative 7. But then minus the number becomes plus its opposite. So plus, and then the opposite of a negative 9 is a positive 9. Well, once again, we have different signs. So that means we're going to subtract our numbers. 9 minus 7 is 2. And keep the bigger number sign. But the bigger number this time was the positive 9. So this will be a positive 2. And then one more here. 2 minus negative 10. First number stays the same. Plus the opposite. Opposite of a negative 10 is a positive 10. And of course, we don't really need the rule for 2 plus 10. We know that. 2 plus 10 is 12. So 2 minus a negative 10 is also 12. Well, ladies and gentlemen, as we get closer and closer to algebra, we're going to start learning shortcuts for these rules, and I'm going to share one of them with you right now. So there's a way to simplify this. In algebra, when we see a minus, we typically look at that minus and treat it like a negative. So we could actually change it to being plus and negative, but we usually just think of it as negative. So I would think of this as a negative 4 and a negative 5, and I'm putting those together. Negative 4 plus negative 5 makes negative 9. I usually wouldn't actually write this. For that matter, when I have 6 minus 8, I'd be looking at this as a 6. I'd be looking at it as a negative 8. So when I put a 6 and a negative 8 together, I get a negative 2. So we kind of skip over this sometimes. The place where we don't skip over this is here and here, minus a negative. And so there's a phrase that's actually more helpful than this one right here. And that phrase is minus a negative is the same as, well, minus a negative is saying as plus, and then that's positive 9, that's positive 10, right? So plus a positive. So if you ever see minus a negative, you want to change that into plus a positive. So the closer we get to algebra, the more we're going to rely on this second statement here. So actually, why don't you draw a little arrow there just to say, hey, this is the one to really focus on. So if we redo the problems from up above real quick here, if I see a negative 4 minus 5, then what I'm thinking in my head is that this is really a negative 4 plus a negative 5. And I don't usually write that, but just I know it's a negative 4 plus a negative 5, and negative 4 plus negative 5 is, well, negative 9. If we think about our number line, you move 4 spaces to the left, and then you move 5 more spaces to the left, well, you're going to be 9 spaces to the left. Likewise, if I had a 6 minus 8, I'm thinking this as, okay, well, that's a 6, and that's really a negative 8, and I'm adding them together. Okay. So if you go 6 to the right, but then 8 back, well, I subtract those, and it's going to be on the negative side. So negative 2. However, if I had a negative 7 minus negative 9, this is where this phrase is really going to come in handy. Minus a negative is plus a positive. So when I see minus a negative, I'm going to just take my pencil and go plus positive. Now you got to be careful. I can't do it here because is this minus a negative? No, this is a negative 4 and then minus 5. But I've got minus negative 9. If you can say minus and negative right in a row, that's where we can use this skill. So minus negative 9 becomes plus positive 9. Right there, that's all I got to write. So now if I think this through, if I go 7 spaces to the left and then I come back 9 spaces to the right, well, that's going to send me all the way over to the right side, 2 spots. Positive 2. Finally, 2 minus a negative 10. Again, I got minus negative, change it to plus positive. And then it becomes super easy. By the way, these last 2 examples here would be considered red light problems. So copying the problem down, obviously, so negative 7 minus negative 9, the work would be changing this to plus a positive. And the answer there, 2. So ladies and gentlemen, let's practice this a little bit more. We're going to go ahead and flip our papers over. And so if I flip my paper over, let's say the book gave you a problem that said negative 7 plus negative 10. That's how the book is going to write it most often. So on your paper, you could just copy down negative 7 plus negative 10. Well, if we think through a quick sketch on a number line, okay, honestly, we wouldn't even need to write out the number line, but if you don't have the rules memorized, just even think through a quick sketch. So if 0 was here, then negative 7 would send me this way, and then negative 10 would send me even further that way. So what's going to happen if those arrows are both going that way? Well, it's going to send you even further into the negatives. In fact, it's going to send you 17 spaces into the negatives, isn't it? So if the book were to give you, let's say, a positive 31 plus a negative 77. Then on my paper, I'm going to copy this down. I don't need the positive symbol, so I'm just going to copy it down as 31. Plus, and then as long as it's clear that that's a negative, I could drop those parentheses. They're not really, really super needed here. So again, if you're having trouble, if you don't have the rules memorized, thinking through a quick sketch can help you with this. And eventually you'll basically memorize the rules. So if this is my number line, oops, sorry, I forgot to mark that as 0 there. So if we imagine 0 being here, okay, positive 31 would send me 31 this way. A negative 77 would send me all the way back to 0 and then beyond that, because that negative would be bigger. So we can just tell right here that the answer is going to be negative. And since we're going to go back that 31, we're going to end up subtracting these. So 77 minus 31, 77 minus 1 is 76, minus 30 is 46. If the book gives me a negative 67 plus a positive 70. Likewise, I'm going to copy my negative 60 down. I'm just going to write my 70 normally. And as you start to get more comfortable with these, you maybe will start to leave behind the sketch and just kind of embrace those rules. But in the meantime, it can be helpful. So if I've got 0 here, a negative 67 would send me 67 this way. Now 70, think about how close those are though. 67 and 70, that's pretty close. So positive 70 will send me back to the right, and it is big enough that it'll get me to 0 and then just a little beyond. In fact, how far beyond? 3 beyond 0, because 70 minus 67 is 3. Next example, let's say the book gave you a positive 26 plus a negative 16. And so here, I'm going to write 16 or 26 minus an, or goodness, I was tripping over my words here. 26 plus a negative 16. So likewise, think through your sketch. Don't actually have to write a nice number line. We could just kind of make it general, do a sketch. So positive 26 would send me 26 this way. 16 though, negative 16, is going to go to the left, but it's not quite enough to send me back to 0. So we are going to be still on the positive side, and then 26, and this will basically be minus 16 then, so it's a positive 10. And then let's say the next problem is a negative 23 plus a negative 18. So I'm going to copy this down, negative 23 plus negative 18 on my homework. And so in my sketch here then, negative 18 would send me 18 this way. 23, negative 23 would send me 23 more that way. So obviously this will be a negative. And if we add those two together, because they're working together, both sending them to the left, further to the left, you'll get a 41. And that's how we add. So if we take a look now at subtraction, let's go ahead and put a line down the page. So for subtraction, let's say we had a positive 59 minus a positive 35. So on my homework, I would just copy this as 59 minus 35. Now this should be pretty obvious. You know how to do 59 minus 35. You would normally just do this and just do it. So I would take 59 minus 5 is 54, minus 30 is 24. Okay. And we don't really, in this case, need to think about that as being positives or negatives. We just know how to subtract that. And when you get to problems like that, that is okay to rely on that old knowledge. However, if the instructions are to change the subtraction into addition, we've got to follow the instructions. So we're going to do this one again, and we're going to assume the instructions were to change this into addition. So if this was an addition problem, 59 so would stay the same, and then the minus would turn to a plus by taking the second number and making it its opposite. So the opposite of a positive 35 would be a negative 35. Now from here, if you think about your sketch or if you follow the rules from the front, this time let's talk about the rules again. So since these have different signs, we are going to subtract them. So 59 minus 35 we already know is 24. And in when we're doing adding with different signs, it's the bigger number sign that follows over to the answer. So the positive 59 makes this a positive 54, or 24, excuse me. All right, next example, let's say the book gave you a positive 47 minus a negative 32. So I would write 47 normally minus negative 32. Now, if the book does not give you the instructions to change this into an addition problem, this is where we're going to use that minus a negative is the same as plus a positive skill. So minus a negative is plus a positive. And from there, we see it's just 42 plus 37. Well, that's 79. On the other hand, if the instructions actually were given that you had to change this into an addition problem, then we would leave that alone as the answer or the problem being copied, and then we'd change it 47 plus the opposite. Opposite of a negative 32 is a positive 32, and it comes out the same. So all depending on what the instructions are. So if the instructions are to just do it, you can do it the way I have written first. If the instructions are to change it to addition first, that's what I've got there second. Okay, we're going to do a few more like this. So we're going to check out negative 77 minus a positive 11. So negative 77 minus, and I would just write 11. So again, as we start getting closer to algebra, we would just look at this and treat this like a negative 77 and a negative 11. And so if you think about your number line, you think about sketching that out, this would be 77 to the left, and then 11 more to the left. Well, that's going to be a total of 88 to the left. So algebraic thinkers would just do it like that. We would treat that minus 11 like a negative 11. Again, if the instructions, though, are to change it to an addition problem, we would leave the first number alone. Second number would become plus its opposite. So plus, instead of a positive 11, now a negative 11. And the answer, still negative 88. Negative 17 minus negative 17. So in this case, I have my negative 17 minus negative 17. Ladies and gentlemen, algebraic thinkers are constantly looking out for that minus negative. So again, we see our minus negative here, so we're just going to change it to plus positive. So I got a negative 17 plus a positive 17. So if we go 17 to the left and you come 17 to the right, you're just going to end up at 0. And actually, that should make a lot of sense. Because if you take a number minus itself, isn't it always 0? Once again, if the instructions are to change this into addition first, we are going to show that separately. And so in this case, the first number stays the same, plus opposite. And then, of course, when the signs are different, we subtract. 17 minus 17 is 0. And you can't have a positive or negative 0. It's just 0. All right, and last one like this. Positive 25 minus a positive 47. So 25 minus 47. So if this was something that we were thinking about in algebra, I would just look at this as a positive 25 and a negative 47. So if I go 25 steps to the right and I come back to the left 47 steps, I'm going to pass 0. So we know that this is going to be negative. Not only that, but since these are working opposite of each other, we know we're going to subtract. So 25 and 47, subtract those. So 47 minus 25 is 22. So this will end up being a negative 22. If this is a problem where it asks you to change it to addition first. Again, the 25 will stay 25, then it'll be plus, and then the opposite of a positive 47 is a negative 47. Following the same rules we just talked about. There you go. So again, just to be clear about these subtraction problems, in each of these examples, the first is what we would do if no special instructions were given. The second is what we would do if we were given the special instructions of showing the addition problem, writing them as addition problems first. All right, ladies and gentlemen, I have run out of space on this sheet of paper, and today is just it's a big lesson. So I'm going to need you to please grab a new sheet of paper, and we're going to put a title up here. This is going to be, Lesson 31. Lesson 31, comma, page 2. We were not going to bother to write the whole title out again. And so I'm going to put my name and then the class. So I'm doing this for both of my pre-algebra classes, and of course you'd put the date on there. So here we go, ladies and gentlemen. The last part of this lesson is about what are called terms. And so in order to understand our terms properly, we are going to come down here several spaces. So I want you to skip 2 spaces, and then skip 3 more spaces, and then I want you to make a rectangle about that big. And you may realize what's coming here. We're going to talk about our pyramid, our math pyramid. So ladies and gentlemen, in the math pyramid, the first thing that we learned how to do in school was we learned to add. Then we learned the inverse of addition, so how to undo that. We learned how to subtract. After a while, we built off of this skill, and we learned how to multiply, because repeated addition is multiplication. And then we learned its inverse, division. So how do we undo multiplication? Division. After a while, eventually we learned a skill building off of multiplication. Repeated multiplication is exponents. And then their inverse are roots. Not just square roots, but roots in general. And then, not that it builds off of these, but at the top of our pyramid, we have essentially the strongest of all the operations. So if you think about addition, 3 plus 5 is 8, but 3 times 5 is 15, but 3 to the 5th power is 243. So it's building up in strength. So at the very top of this, it's not repeated exponents, but it's just stronger than everything, are our grouping symbols. So represented by parentheses, but also including brackets, braces, and absolute values, as well as a few other things that we'll get to in time. So ladies and gentlemen, if we think about this as a power structure, then what's going to come out of this is that the strongest 3 layers here, so things that we typically represent as parentheses, exponents, multiplication, division, that these are powerful enough to group numbers and or variables as part of one term. So up here in the first space that I skipped, I'm going to make a bullet point. Terms are grouped together by multiplication. So if 2 things are being multiplied, they're part of the same term. Division, which we typically write as a fraction. So all fractions are a single term, and anything in the fraction is part of the same term as the fraction as a whole. Exponents So the exponent and its base are both part of the same term. Roots, so everything involved in the root, the radicand, the index are both part of the same term. And then finally, anything inside of any grouping symbol, such as parentheses, are part of the same term. So it doesn't matter what's inside those parentheses. If there are parentheses, that's part of the same term. So this leaves the bottom layer of our pyramid, the addition subtraction, this weakest layer. Oh, sorry, before I forget here, let's highlight whatever color you chose for the top 3 layers. Highlight that bullet point with that same color there. There you go. So here, addition and subtraction, however, is just too weak. It's too weak to group anything together as one term. So instead, these separate terms. Terms are separated by addition and subtraction. So we could also say that terms, when you write a group of terms out, that they are being added and subtracted with each other, because it's addition and subtraction that separates them. So up here, I'm going to make a second bullet point, and I'm going to highlight that with my blue before I forget, since that bottom layer for me was highlighted in blue. And so if they're grouped together by the top 3 layers, they are, oops, I forgot my S. There we go. They are separated by addition and subtraction. So let's take a look here. For example, if I gave you the expression 3 plus 2x minus 5y minus 6x plus 4 minus y, and I asked you to tell me how many terms are here, what I would recommend that you do, at least for now here at the beginning, is to grab this bottom layer color. So that's my blue. Addition and subtraction separate the terms. So I'm just going to take my blue and I'm going to underline everywhere that I have addition and subtraction. That is separating my terms. So what are my terms? Well, 3 would be a term. It's all by itself, but it's still a term. 2x really means 2 times x, so both of those get highlighted with green because we're multiplying them together. They're part of the same term. 5y, likewise, would be part of the same term. 6x would be the same term. 4 would be its own term, and y would be its own term. And so if we do a quick count here, this is my first term, my second term, my third term, fourth, fifth, and sixth. So this has 6 terms. And just to be clear, what are those terms? Well, the first term is 3. My second term is 2x. My third term is a little tricky. You might be tempted to say that my third term is 5y, but that would be incorrect. Remember that as we start getting closer and closer to algebra, that we're going to treat minus signs like negatives. So my third term is not 5y, but a negative 5y because of the minus in front of it. So therefore, my fourth term, hopefully you've caught this, is negative 6x. My fifth term is 4, and my last term then is a negative y, which means really negative 1y. It's a hidden 1 there. So negative y or negative 1y. I'm going to give you another expression, and this time I want you to see if you can figure out how many terms there are and what the terms, which terms are present. So 2x cubed plus x minus 4 plus 3x plus 9x squared minus 5x cubed plus 1. So go ahead and pause the video, take a moment, see if you can figure out how many terms are in this expression. All right, let's see how you did. So just to help me out, okay, I'm going to kind of go back and forth here. So I've got my 2 times my x with an exponent 3. Those are all part of the top 3 layers, so that's one term. Then I hit this plus, so that's separating. X is all by itself, because then I have a minus. 4 is also all by itself, because then I have a plus. Then I have a 3 times x, so that's part of the same term. Plus separates the next one. 9 times x squared, so the times and the exponent all part of the same term. But then I have a minus here. And then 5 times x cubed, again, the times and the exponent, same term. Plus separates, and 1 is all on its own. So if I count these guys up, I have 1, 2, 3, 4, 5, 6, 7 terms this time. And what are my terms? Well, this is a 2x cubed. This is an x, which really is a 1x. Then I have a negative 4. I hope you all caught that negative there. So since it's a minus 4, it's really a negative 4. I have a 3x, a 9x squared, a negative 5x cubed, and then, well, just a plain old 1. So ladies and gentlemen, once we have this established, we can now take a look at how to combine like terms, or as the title says, collect like terms. I've very rarely heard it expressed as collect like terms. Most of the time I've heard it expressed, it's been combine like terms. So just a heads up, you're going to hear me say combine a lot. So if the book says collect and I say combine, we mean the same thing. It's just a matter of how you choose to say it. So like terms. Like terms are terms with the same variables. And this is including the same exponent on each variable. So if something has an x, one term has an x, another term has a y, these are not the same. So if we look up here at this example, a negative 5y and negative 6x, this has a y, this has an x, these are not like terms. However, 2x and a negative 6x, they both have x in them. These would be like terms. For that matter, my negative 5y and my negative y, these would also be like terms, they both have a y. My 3 and my 4, since there are no variables, those would be like terms. These are called constant terms since they don't have any variables. Constant terms are always going to be like terms. They don't have any variables, well, that matches. Having no variables and having no variables can be a match. If we look at this example here, we've got some like terms in here as well. Now you might be tempted to say that 2x cubed and x are like terms, but you'd be wrong, because we've got to look not just at the variable, but also the exponent on the variable. So an x cubed and just a plain old x are not the same. This actually has 3 x's, whereas this is just a single x. So x would be like terms with 3x because they both have just a single x. My 2x cubed would be like terms with my negative 5x cubed because they both have an x cubed. So what would be like terms? A 7x squared and an x squared. A 3 AB, and 83 AB. Since these both have AB in them, these both have x squared in them. For that matter, 5xy and 6yx. So here you'll notice that this is an xy, but this is yx. But guys, multiplication is commutative. So xy and yx are really the same thing. So as long as you have the same variables, we're good. Now we do have to be careful. 4a squared b and 8ba squared are like terms. Because I've looked at how many a's and how many b's do I have here. I have 2 a's and 1 b. Well, over here, how many a's do you have? How many b's? 2 a's, 1 b. So they match each other. However, if I had 9x squared y cubed and 9x cubed y squared, well, you've got 2 x's here, but 3 x's there. You've got 3 y's here, but only 2 y's there. This would not be like terms. So, ladies and gentlemen, since terms are separated by addition and subtraction, we combine them by adding and subtracting, specifically the numbers. When we combine like terms, though, the variables stay the same, and that includes their exponents. So, for example, if I had 3 plus 2x minus 5y minus 6x plus 4 minus y, like we did from up top, if we take a look at this and we look at what terms we have here. So first of all, I'm going to grab my yellow. Here. I'm going to turn my paper sideways. Since this has no variables on it, this is what we would call a constant term. Constant term. If we look to our next term, the 2x, since this has a variable x in here, this is a different kind of term. I'm going to grab my orange for this. And since it has an x in it, the number doesn't matter for what kind of term it is. It's the variables that matter. So since this has an x in it, it's an x term, and that is hyphenated. X term. X hyphen term. All right, flip back. So minus 5y, negative 5y is my next term. Since it has a y in it, this makes it different from my constant term and my x term. It's going to be a y term. Next up, I have a minus 6x. This has an x in it. Oh, if it has an x in it, then it's on x term. So that's like my orange one over there. So this is another x term. My 4 doesn't have any variables in it. This makes it a constant term. So we got another constant term. And then finally, my y all by itself, the negative y there. Well, that negative y is like my negative 5y. They both have y's in them. So that makes that my pink, or whatever color you chose. That's another y term. So in order to put this together, I'm going to add these up. Let's give this just a little bit of space there with the equal sign. So we can tell a little easier that this is what we started with, this is going to be my answer. So with my answer, we typically like to, it's not required. We'll worry about that for a different day. So let's go ahead and start adding things up. So first I have a constant term, and I have another constant term. So this is a positive 3 and a positive 4. Positive 3 plus positive 4 makes a positive 7. And so you'll notice that my constant terms add up to make a new constant term. All right, let's move on then. Next up, I see my x term, 2x. Well, it's also a like term with my negative 6x. These both have x's in them. So what I'm going to do is I'm going to add the numbers. So positive 2 and a negative 6. So to the right, come back 6 to the left. That's a negative 4. And it's still an x term. Biggest mistake students want to make here is they want to turn that into an x squared. No. When we combine like terms, it's just the number out front that's going to change. So the variables have to be the same and they stay the same. It's kind of like fractions in a way. You got to have a common denominator, and once you're done adding or subtracting, you still have that common denominator. Okay. If you make that connections with fractions, that can be helpful here. All right, finally, last of all, my y term. I do have a negative 5y and a negative y. Remember, this is really a negative 1y. So 5 to the left, and then 1 more to the left will make a total of 6 to the left. And if it was a y term before, then it is a y term after. So, ladies and gentlemen, we're going to take a look now at our second example that we did up above. So 2x cubed plus x minus 4 plus 3x plus 9x squared. I lost my track. There we go. Minus 5x cubed plus 1. Now with this one, since we got x and we got exponents and we got constant terms, this one can be helpful if we do go through and we try to put things in order, like starting with the highest exponent first. So if I start with my highest exponent first, I've got some x cubes. So I've got an x cubed right here, and I got an x cubed right there. So these would both be what we'd call x cubed terms. So let's just start by putting those together. So we'll leave a little space there. So I got a positive 2 and a negative 5. Positive 2 plus negative 5 gives me a negative 3. And that'll still be, x cubed. I started moving on to the next problem in my head. So now just to make it nice, let's go down now to our x squared terms. So if I look for my x squared terms, that's just an x, that's a constant, that's an x squared. Okay. So 9x squared, that's x cubed, and that's a constant. So it's just that one. That makes it easy. This is my only x squared term. Sorry, it really should be x cubed term there. There's only one at each spot. So anyways. So since that's the only x squared term, it's just going to get copied over. There's nothing it can combine with. If it does not have any like terms, it just gets copied. Now let's go down to our x terms. So for my x terms, we're looking at what's left. So this is just a plain old x by itself, so that's an x term. That's a constant. 3x is an x term, and that's a constant. So I've got those two x terms. X is an x term. It's really one x, remember. And then 3x is my other x term. So to combine like terms, we add those numbers. 1 plus 3 makes 4. So this is plus 4, and it's still an x term. And then finally, my constants. I got a minus 4, which is really a negative 4, and a positive 1, which, well, is really a positive 1. So this is my constant term. There's my other constant term. So constant term plus a constant term. So a negative 4 plus a positive 1 would become a negative 3 constant term. And ladies and gentlemen, that's how to combine like terms. And that is the end of our lesson.